Well, I'm not sure how far you went in algebra 2 if you did like three systems or a system of three equations. But I know in algebra 1 you do systems of two equations. That's where you have to solve two equations at the same time to see where they match up. So you're looking for a point that would work for both equations. Sometimes there's points that they share, sometimes there's not. So if we have two equations like this, what we're going to do is we can solve it three ways: substitution method, elimination method, and then we have the graphing method. And graphing method was definitely probably the most work, especially if the numbers weren't nice. So in algebra 1, you guys always had nice numbers, nice whole numbers that worked out perfectly. You could find your y-intercept, you could use your slope, everything worked out really nice. The problem is that, like, in real life, not all numbers are nice whole numbers. Sometimes you get crazy, may get irrational numbers as answers. You might get crazy fractions. And it's really hard to tell on a graph if two lines cross at a decimal and to find the exact value, especially without a graphing calculator. So substitution and elimination will always get you the right answer. Sometimes, though, algebraically, they can be sometimes they're impossible to solve. If you, back in algebra 1, you guys just found where two straight lines cross. Those are easy to solve. But let's say I've got a function that looks like this, and then I've got a function that looks like this. These two graphs cross three times. So they have 3 points in common. They're going to have the 3 solution points. The problem with this is sometimes these functions are not easy to solve for y. So we may have to use the graphing calculator to graph it and find the answer. So we're just going to review some easy stuff just to review how to do it the algebra way. And then my other class told me they never did this on their graphing calculator. So I'll teach you guys how to do that. The only time we don't use trace too. Okay, so substitution method, that is where we plug one function into the other. So I already know what y equals. I can take this equation and plug it in for y. And then we just have an equation that we can solve for x. So there's lots of ways to solve this. I typically like to get rid of any fractions first. Like, there's an easy way to not have to deal with fractions. What can I multiply everything by to get rid of that fraction there? 2, yeah. If I multiply everything by a 2, these cancel. I'm left with negative x plus 12 equals negative 6x minus 8. I avoid now dealing with fractions, which nobody really likes anyway. And then I can easily solve for x. I'm going to add 6x over. That gives me 5x. I'm going to subtract 12 from both sides. That gives me negative 20. So x is negative 4. Then you would find the y value. So to do that, we pick, doesn't matter which one, I'm going to pick one of these. I'm going to use the bottom one because I think the math is going to be a little, they're both about the same. Y equals negative 1/2 times negative 4, that's positive 2, plus this, so y is 8. The other way you guys would have solved this in algebra 1 is elimination method. Let me erase this so I don't have all this in my way. So elimination method means we want to cancel things. And what you would have done is you would have needed an opposite. So everything also has to line up. The y's, the x's, and the constants all have to sit on top of each other. So what you would have done is you would have gotten an opposite like y, and I want a negative y. That gives me an opposite, but what I do to one side of an equation, I have to do to the other side. So I'm going to change all the signs over here as well. Then we added the two equations together. So negative y and y gives me 0. If I add negative 3 and 1/2, that's negative 2 1/2. So negative 5/2. And negative 10. Add that sign over. And multiply by the reciprocal, so negative 2/5. So negative 20 over 5 gives me negative 4, which is what I got over here. And I'm going to also get y equals 8. Okay, graphing. Back in algebra, you would have started with your y-intercept, used your slope, you would have done both lines, and this is nice because the answer would have been easy to find because the answer are nice full numbers. So on the calculator, this is going to be the new part today. Let's get your calculator out. Let's open up a graph page. We have two equations, right? They're both already y equals. So if you're not in f of x mode, you're going to go to menu, graph entry, number 1. Go back to function. Okay, let's type those two in that we have. Negative 3x minus 4 was the first one. Line 1. Press tab. Second one was negative 1/2 x plus 6. Now, they're going to cross over here in this spot I can't see. So I want to see it. I'm going to click anywhere in the blank space, hold it down, and then I can pull the graph down so I can see where they cross. Now, the trace button does a lot of things, but the one thing it doesn't do is it won't find where your two lines cross. So this is going to be a new thing. It's not under trace. Okay, we're going to go. We want to find where they cross. Anytime I want to do something on my calculator, I'm going to go to menu. And if I'm not using trace, the only other option that we're really going to work with to do something is to use analyze graph. So go ahead and click analyze graph. And now you'll see 0, min, max. Now trace will do all of that for us. That's why I don't use this. But number 4 is intersection. That's what we want. You're going to see this little dotted line pop up. Menu, analyze, intersection. Does anybody not have that dotted line and need help? You got it? Anybody need help? Okay. Now your calculator is going to ask you a question. Down at the bottom it says lower bounds. Lower bounds? And that's asking, so because like I showed you in that graph before, you might have graphs that cross more than once. Your calculator wants you to tell it like, which point are we talking about? This graph clearly only crosses once, but your calculator is not always smart. So we have to kind of lead it in the right direction. So what I'm going to do is I'm going to say, well, the point is between here and here. Tell me where it's at. So I'm going to click anywhere to the left of where it crosses. That would be my lower bound. That's my starting point. And then I'm going to click anywhere to the right. That would be my upper bound. So I'm telling my calculator that point is between here and here. It's in this region. And it should come up with the answer, -4/8. Oh gosh. What happened? Oh, we got it. We didn't get it. Oh. No. Yep. Anybody need help? Okay, you guys definitely didn't do this on the calculator last year? No? Okay. I've never seen this before. Okay. It's like the crash course in using the calculator then. Okay. Let's go to the math. We're going to do number 1. Delete, delete, delete. Yep, delete, delete, delete. Now, I usually just leave my graph. Some you can reset it, but we're probably going to have to move it anyway, so I'm just going to leave it. Press tab. Okay, the first line is negative x plus 8. Press tab again. Okay, now this one, I can solve it for y, or we can delete this out and type it in as a relation and just type it in. X minus y equals 4. Uh-oh, turn the AC off on us. Okay, now I want you guys to practice finding where they cross. Intersection? Yes. Menu, analyze, intersection. You can actually stay in relation the whole time. You can type in y equals every time if you don't want to have to switch between f of x and relation mode. I'll go through it up here slow if you're stuck. I'll go menu, analyze, intersection. I'm going to click anywhere to the left of where they cross. Yeah, actually click it. Then I'm going to move over to the right and click. You should see 6-2 pop up, right? Okay, we're not going to draw a sketch. Let's just write our answer in here, 6-2. It's a lot faster than having to do it any of the other ways. And it's especially nice that we don't have to solve for y. So even, like I said, there's going to be ones that aren't solvable anyway. Okay, let's try one more. Delete, delete, delete. Y equals, so I'm not going to switch back to function. I'm just going to type in y equals 2x plus 6. I'm gonna zoom out. You don't have to zoom out. I just want to zoom out to show you. What's the solution point?
Nothing.
Nothing. What do we write when they don't cross? No, they're functional. No solution.
I was so
Now, the next one. Is it the last one? It's not the next one. Not that one. Or maybe it is. Negative x. The last one. Yes, the last one. The last one ends up being the same line. I'm just going to skip ahead here. Oh, maybe not. I'm going to skip ahead to the last one really quick and show you what that looks like. Tab. Oh. There's too many tabs open on my screen right now. Okay. Negative 2x plus y equals negative 2. 2x plus y equals negative 4. I think that's what it was. Yeah. Y equals 2 times x minus 2. Okay, so when I graph the last one, I end up getting the same line, one on top of the other. So, yes, all the points they share in common. So you guys wrote all real numbers. You could also say infinitely many. There's also a symbol for all real numbers that saves you from writing all those words. Yes. Good. Very good. My other class didn't know this.
well, you know, they do say.
So tomorrow we're going to do review. We'll take our test on Monday.